Okay, so today we're going to look at the theorem for the theorem for integration by substitution. Okay, so in this case, this is the theorem that's going to allow us to be able to do integration by substitution. So what it says is substitution with indefinite integrals. So again, we're going to just talk about indefinite integrals. If we let u be g of x, where g prime of x is continuous over an interval, we're going to let f of x be continuous over the corresponding range of g. Okay, so that's the setup. And then we're also going to let capital F of x be an antiderivative, okay, of f of x. Okay, so that's the setup. So then we're defining those functions. Then this is true. The integral of this function, notice it's the chain rule, right? The integral of this function, which is the derivative of the chain rule, is equal to the integral of f of u du, if we do u substitution, which is equal to capital F of u plus c, again, using the what we know about indefinite integrals, right? We have to have our integration constant of integration here. So, because again, this represents a family of functions, okay? And then what we can do is we can go back and substitute back in for u, g of x. So what we're doing is we're letting u be g of x, okay? And then we do this. So if this is true, we can always do a u substitution. So what's the proof? Well, it's a pretty straightforward proof. And so we're going to show that this is going to be true. Okay, given this information, okay, we're going to show that this follows from that. So we're going to let f, g, u, and f. So So again, we're just taking f, g, u, and f defined or specified as it was in the theorem. Now, so what we're going to do is we're going to take the function f of g of x. So we have a composite function, right? So we're going to take capital F. Oops, let me. So capital G, f of g of x, and what we're going to do is we're going to take the derivative of this. So we're going to take it with respect to x, so we're going to take the derivative of this with respect to x. And so what do we get from this? Well, we get f prime yeah, that's fine. F prime of g of x, right? So we're taking, it's going to be the derivative of the outside function times the derivative of the inside function. And then of course the derivative of capital F is f, because again, f is the antiderivative, so the derivative of this will give us f. So we're going to write f of g of x times g prime of x. Okay? So far that's what we have. Now what we're going to do is we're going to integrate both sides. Okay? So what I'm going to do is I'm going to write it this way. So let's write it this way. F of g of x times f prime of x equals the derivative of f of g of x. So that's, I just switched it around. And so now what I'm going to do is I'm going to take the derivative, or the integral of both sides. And what do we get? Well, over here, we get that. Right? So this here is what we started, this is where we ended up with. So now what we have to do is, okay, well what happens over on this side? Well, the integral of a derivative is just going to give us back our function. So we get f of g of x plus our constant of integration, right? Because this is a antiderivative, right? So we get some f of g of x plus c. Okay. Now to see that this is true, all we have to do is start with our u substitution, right? So let's do our u substitution. So now let's just do, we're going to make u, right? Is g of x. Du is g prime of x dx. And so what do we get? We get the integral of, f of u du, which of course is equal to capital F of u plus c. And then of course if we substitute back in, it's f of g of x plus c, which is what we had before. And that's it. So if you have any questions, let me know, but that's the end of the video. Thank you.